Hello, everyone. Welcome to part 2 of lecture 6. In this video, we're going to cover the moving averages, their calculations, and their use in the trend following strategy. So, moving average is also called a rolling average, and it is the summary of a statistic called an average, which we know how to calculate, of a certain window, right? So now the data falls into the window. So first we choose a window to give us the specified data. For example, it could be the closing price, and the data points falling within this window are really continuous, right? So they are consecutive periods, not necessarily there's a gap in between. So this is how we choose a window in the historical data space. And then we calculate a statistic called an average. And we're going to use this average to represent to constitute new price curve, right? So as new data becomes available, then the mean is calculated by dropping the oldest values and add the latest ones. So think of it as a fixed window, and this is the direction of time, and this is so as new data comes in, right, and we're going to shift the window here, so our window becomes here. So previously, the data falling into the window is this range, and as we move into the future, then we have some new data, and this set of data gets ignored, right? And then we have another window with the same size, and we have some new data. So each window reports a single statistic, which is the average, the mean, right? And then we have another mean here. And then these means form a new curve. So this is just single point. It's not single point. We have multiple single points. We just connect them together. This represents the moving averages. So the net effect of a moving average can be considered as smoothing the time series, the original time series. So that's, or in the original time series, we see the short-term fluctuations, right? And we have temporal variations as well, temporary. But now, once we take the average, these oscillations will cancel each other out, and we simply have a smooth curve, smoother curve. So that's the reason why we use the moving averages, which is to smooth out the short-term ups and downs, and then we see the longer-term trends. So there are different ways to calculate a moving average. One way, or the most common way, is to use the so-called simple moving average. So to calculate simple moving average, we just take the list of price points falling into the window. So we start at the current time point, and we move back to say we have m points here. So this is m minus 1 because we are taking the current time points into consideration as well. So this really, so this summation works as the historical prices for size of n, and then including the current time point. And we just add them up and then divide by n. So this is to calculate one average point. So the move average essentially is an unweighted mean, right? So it's unweighted. So we're taking all the historical points up to timestamp of n plus 1, right? And then we add up. So essentially, if we divide this m to each element here, so the weight is essentially 1 over n. So it's unweighted because we treat every historical point the same. So m is a user-defined input. We can make it shorter, we can make it longer. It depends on the amount of smoothing effect desired, right? So there are two cases here. If m here is short, is small, right? And then the corresponding smoothing effects will not be very big because we're only focused on a few points, a few historical points. However, when we want when the M is very big, so increasing the value of M, then we're taking more historical price points. And the averaging effect is more obvious because there are more historical values. So this will result in a smoother curve. Right. So increasing the M results in a smoother curve, and then smaller M reduces to a less smooth curve. So let's continue. Now with the calculations. To calculate the moving average series, so we're going to use a new column called the SMA3. And then the calculation works by taking the series, for example, the adjusted close, right, and calling the method, which is rolling. So rolling really means to roll the series either up or downward in sequence for a fixed window size. So, and then take the average or take the mean. So let's look at it. So originally we choose the window size to be 3. Now, if you look at this point, so if we look at this point and then the rolling, what it does is to move it upwards by 2 units, because including current period, it's going to be 3 units. So moving back, then we have a unit of 3 price points, right? So this is what rolling does. And then we're going to apply the mean methods, which is to calculate the average, and then it gives me the price point here, right? So we can verify the calculations by explicitly taking the first 3 points, first 3 prices divided by 3, gives me the same value. So this is essentially how it works in codes. Now the first 2 price points are empty because if we shift it further up, there's no value here. Further up, there's no value here. That's why it's empty here. But there's a way to say, when we are at the beginning, right, I'm just going to take whatever I have. So this is this specification is available in the codes, and then in this way, then you will not have the value here. So there's a special treatment for the initial values as well. Okay, so that's how we calculate the moving average. And let's see the results. So here we're calculating 2 averages, 2 moving averages. First one is with M equals to 3. This is the right line. And another one is with M equal to 20. So we see that we just mentioned if M increases, it will result in a smoother curve. And this is indeed the case. You see the green line is looking smoother than the other lines. And this is really because each point here, for example, each point, its calculation requires the past 20 price points, 20 price points, and then take the average. So this is a much more obvious smoothing effect. However, when M equals to 3, the smoothing is not obvious because we're going to take a very short window, and then the curve, which is in red, is still mimicking the original price points very much, right? Except for some extreme ups and downs. So that's the difference here. And let's look at another type of moving average, which is called the exponential moving average. So this is again another method widely used, and there's a key difference here. So EMA or exponential moving average assumes that recent data is more relevant than old data. So this contrasts the previous method, which is to have equal weightage for all the points. Now EMA assumes that recent data is way small, right? So there's an advantage here. There's a merit. The merit is that EMA can react faster to changes in the recent periods, so that it's more sensitive to the recent movements in price, right? So shows more sensitivity to the recent periods, but subject to a control parameter, so which is called alpha. If you look at the definition of EMA, or we can call it EWMA, exponentially weighted moving average, its calculation essentially current price point ST and historical exponential moving averages, and this is a weighted combination with the weight alpha given to the current periods, and then 1 minus alpha given to the historical moving averages. And we know that, of course, R is a value that ranges from 0 to 1, right? So you see this formulation does not involve a window size. So which means we just need to choose the value of the alpha between 0 and 1, and then the calculation will proceed. So let's compare the different moving averages. If you look at the EWM 0.5, which means alpha now equals 0.5. So we're giving equal weightage to the recent price, which is the ST, and the historical the moving averages, right? So this is equal weightage. And now what this results is a curve that's actually very closely tracking the original curve, right? So so this is treating the historical price points averages equally important as current price points. However, when we changed alpha to 0.1, now this says that we only give 0.1 weightage to the current price, but much more weightage to the historical prices. And that means that the smoothing effect is more obvious, right? And we see that you see the red line here, the red line is looking much smoother than all the other lines because we're assigning 90% weightage to the historical prices and only 10% to the current period. So that's how we adjust the smoothness of the resulting moving averages. Now let's talk about the trend following strategy, and this is where really the juice is. So the juice is generated by the so-called crossover points. So first we have the original time series, right? And based on the original time series, we create two curves. One is the short-term smoothing average with a period with a window size of 3. The other one is the same moving average with a window size of 20. So this is a short-term moving average. This is a long-term moving average. And we want to use these two moving averages to generate the trading signal. And specifically here, you see that when the short term goes below the long term, right? So it goes below the long term. So the orange curve is going up below the green curve. Then what this means is that short term wise, I'm seeing a momentum that's actually pushing it to go down below the long term trend, right? And that's a signal for me to sell because I'm seeing such a big momentum, such that it causes the long-term trend and pushing the asset price to go down. And you see that it's indeed going down. It verifies our assumption. So in the case when the asset price is dropping, right, so it's pushing it to go down and asset price drops, we will make profits when we are in a short position. So this, which means this red triangle downwards means that we're going to enter into a short position so that we can profit. Otherwise, if you hold this position in the long position, then you're going to lose profit, right? Lose money. So this works the same with, for example, we're going to enter into a long position here because the short-term trend in orange exceeds the long-term trend in green, right? So that's a crossover here. That means that we're going to make a trading action. However, when we make intraday action, if we look at what's happening afterwards, we're going to maintain the same position because we see the short-term prices are still above the long-term price points. So in other words, the crossover really means that there's a change of sign here, right? Change of the relative magnitude, the short-term and long-term. So if there's a crossover, if there's a change, then we make a trading action. If there's no, then we maintain the position as it is. And then, of course, the whole process, we're only dealing with the historical prices of the stock itself, right? There's no comparison of the other stocks. So this is also called using the absolute momentum strategy. Later of the course, we're going to cover the momentum trading strategies, which is another type of strategy to compare the different stocks, right? And that's another different angle. But here it's just using the spawn prices itself to determine the trading actions. All right, so that's it, and thanks for watching.